Hello everyone. In this lecture, we are going to discussing about the relation between the Young's modulus, shear modulus, bulk modulus and the Poisson ratio. First, we are going to discussing about the what is the bulk modulus. Bulk modulus is the ratio of direct stress divided by volumetric strain. But condition is body should be subjected to three mutually perpendicular equal intensity of stress. Let's see, when a body subjected to three mutually perpendicular like stresses of equal intensity sigma. Let's see the diagram. Here, body is subjected to three mutually perpendicular stresses which having the equal intensity, that is sigma. Then ratio of the direct stress sigma to the corresponding volumetric strain epsilon v is defined as the bulk modulus. Then bulk modulus K is ratio of the direct stress to the corresponding volumetric strain. So K equal to direct stress divided by volumetric strain. So K equal to direct stress, that is the sigma, volumetric strain, that is the epsilon v. So you have to remember this formula. So we know that when the volumetric strain, epsilon v is nothing but change in volume, so that is the delta v divided by the original volume, that is the capital V. So next we have to see the relation between the Young's modulus and bulk modulus. Let us consider a cube, so which is having the side length of capital L and it is subjected to three mutually perpendicular like stresses of equal intensity sigma as shown in figure. So in the diagram we have to observe that one, the cube having the side length of capital L and it is subjected to a mutually perpendicular like stresses of equal intensity, that is the sigma. So here in the three mutually perpendicular directions we are applying the equal intensity of the stress, that is the sigma, and the nature of the stress is the tensile. So next we have to calculate the linear strain of the cube, that is, let us consider the epsilon. We know that when the epsilon equal to sigma 1 by E minus of sigma 2 by m by E minus of sigma 3 by m by E. Here sigma 1 equal to sigma 2 equal to sigma 3, which is equal to the sigma. Then we have to write down the linear strain, that is the epsilon equal to sigma by E minus of sigma by m by E minus of sigma by m by E. So we know that one, the linear strain which is nothing but for the cube, so change in length divided by the original length. So then this is we have to write down the delta L by L equal to, here sigma by E have to take the common. So this equation will become delta L by L equal to sigma by E into 1 minus 2 by M. And we know that when the volume of the cube is which is equal to the L cube, then we have to derive the volume with respect to the L. So then this is will become dV by dL. So here this derivation with respect to L, it is will become the 3L square. So then this equation once again I have to write down the dV equal to 3L square dL. So here dV, this equation once again I have to write down dV equal to 3L square dL into L by L. So then this equation will become dV equal to 3L cube dL by L. So we know that one, the dL by L is nothing but change in length divided by the original length, that is the delta L by L. So we know that one, the dL by L equal to sigma by E into 1 minus 2 by M. Then you have to substitute this dL by L value here. Then this equation will become dV equal to 3L cubed into sigma by E into 1 minus 2 by M. So we know that when the L cubed is which is equal to the volume. So this is, it will become 3V here, 3V into sigma by E into 1 minus 2 by M. Then you have to bring this V equal to here. Then it will become the dV by V equal to 3 into sigma by E into 1 minus 2 by M. So we know that one the change in volume divided by original volume, which is equal to the volumetric strain. Here we are representing the epsilon V. So epsilon V equal to 3 sigma by E into 1 minus 2 by M. See just here, so have to bring E here and have to bring the epsilon V here. So then this equation will become E equal to 3 sigma divided by epsilon V into 1 minus 2 by M. So we know that when the bulk modulus is direct stress divided by the volumetric stress. That is the sigma by epsilon V. See in this equation I have to observe that one the so sigma by epsilon V is there. Then we have to replace with the sigma by epsilon V with the K. Then this equation will become so E equal to 3K into 1 minus 2 by E. So this is the very important formula. You have to remember this is the relationship between the Young's modulus and bulk modulus, which is the E equal to 3K into 1 minus of 2 by M. Just have to remember this formula. So next we have to find the relation between the Young's modulus, shear modulus, bulk modulus and the Poisson ratio. In the previous lecture, we already derived the relation between the Young's modulus and the shear modulus, that is the E equal to 2G into 1 plus 1 by M. So this formula also have to remember. And just now we derived the relation between the Young's modulus and the bulk modulus, that is the E equal to 3K into 1 minus 2 by M. So from these two equations we have to observe that one, we have to once again have to rewrite. So which is the here 2G into 1 plus 1 by M equal to the 3K into 1 minus 2 by M. Then we have to solve this equation. So we will get the 1 by M value in the terms of the E and G. Then we have to solve this equation. Here 3K minus of 3K into 2, that is the 6K divided by M. So 3K minus of 6K by M equal to here 2G into 1, so 2G plus 2G into 1 by M, that is the 2G by M. So this equation once again I have to write down the 3K minus of 6K divided by M equal to 2G plus 2G by M. So just I have to bring 2G here and bring the 6K by M here. Then this equation will become 3K minus 2G equal to 6K by M plus 2G by M. So here we have to take the 1 by M is the constant. Then 3K minus 2G equal to 1 by M into 6K plus 2G. Then finally 1 by M will become the 3K minus 2G divided by 6K plus 2G. So this is also very important formula. In the examinations, just they will give the Poisson ratio and the G value. Then maybe question will be asked the find the K value. So for this one, just we have to remember this formula. So 1 by M equal to 3K minus 2G divided by 6K plus 2G. And then we have to substitute this 1 by M value in the any equation in the above this equations. We will get the relationship between the Young's modulus, shear modulus and the bulk modulus, which is the E equal to 9kg divided by G plus 3k. So here I have to remember this formula also. So finally I want to conclude this one. So these four formulas are very important for the exam point of view. So mostly they will ask the question is, they will give the data. So maybe they will give the direct strain or maybe lateral strains and also maybe Poisson ratio. Maybe we have to determine the E, K and G values. So for this one we have to remember these four formulas. Thank you very much.